Hi everyone, let's solve the following problem. Let f of x be cosine of 5x to the power 4 minus 1 over x to the power 7 and evaluate the 90th derivative of f at x equals to 0. Let's divide a couple of steps. Step 1. Use the MacLaurin Series formula, and then we're going to figure it out that cosine of x is equal to sum from n equals to 0 to positive infinity of minus 1 to the power n times x to the power 2n over 2n factorial for all x. Step 2. Let's replace x by 5x fourth. Okay, replacing that, we're gonna have the series from n equals to 0 to positive infinity of minus 1 to the power n, 5 to the power 2n, x to the power 8n over 2n factorial. Still for all x. Great. Now, step 3. Since you know cosine of 5x to the fourth is equal to that, I can just write down in a different way. Let's apply n equals to 0 in my series and take this number out of my series. So if you plug 0, we're gonna have actually 1, because minus 1 to the power 0, 5 to the power 0, x to the power 0 over 0 factorial. That's 1. Okay, and now we're gonna have my series starting from 1 to positive infinity of minus 1 to the n, 5 to the 2n, x to the 8n over 2n factorial. It means cosine of 5x to the fourth minus 1, it's going to be equal to the series from n equals to 1 to positive infinity of minus 1 to the n, 5 to the 2n, x to the an over 2n factorial. Right? Yeah, and basically that's the reason that I took my number 1 out, because I knew it would be cancelled with this minus 1. Okay, now divide by x to the power 7, both sides of my equation. On the left hand side, I have my function f, and in my right hand side, I'm going to have the series from 1 to positive infinity of minus 1 to the power n times 5 to the power 2n, x to the power an minus 7 over 2n factorial. And then I can write now my function f. Look, the first 4 terms. Minus 5 over 2x plus 5 to the power 4 x to the power 9 over 4 factorial minus 5 to the power 6 x to the power 17 over 6 factorial. And then you can keep going. When you apply the derivative, we're going to see what is happening. And now, look at when you plug the 0 at your function and at your derivative. At your function, f of 0 is 0. At your derivative, f prime of 0 is minus 5 over 2. Okay, so do I actually need it? Compute 9 times the derivative of this? Is there a reason they are asking us to compute the 90th derivative at my function? Because I know how to compute the derivative. I could basically apply the quotient rule here and also the chain rule for the cosine, and it will be fine. But they are telling us that because there is a reason. It's easier to see what's going to happen with your derivative. If you compute your second and your third derivative, you're going to realize that the only term that actually mattered was a term that had the power 9, and my coefficient is gonna be 9 factorial, because it's every time that I'm applying the derivative, my power goes down. So it means I'm gonna have, when I apply the first time, I have 9, and then the second I have times 8, and then times 7, and then times 6, 5, 4, 3, 2, 1. That's 9 factorial. Times 5 to the power 4th over 4 factorial. And then I have all the terms, but all the terms is gonna have x. And then when you apply 0, doesn't matter. The only thing that matters is the coefficient that was in front of my power 9 at the beginning of my function f, and then I'm going to add the 9 factorial because it's going to come from the 9 derivatives that you're taking. Every single term that has power less than 9 is going to become 0. Every time I have power that is greater than 9, when you apply at 0, it's going to be 0. Okay, and then we have your answer. Great. I hope you guys enjoyed the video. Give us a like, subscribe to the channel, and see you soon.